Noah, have you noticed all the vampires in your house?
Vampires? There's vampires in my house?
Not actual vampires, we're talking about vampire electricity.
Energy vampires are electronic devices that passively drain power even when they're turned off or on standby mode.
Laptops, ovens, TVs, microwaves, and cell phone chargers are all energy vampires.
We spoke to an expert in energy. Her name is Mrs. Lacey Goldbranson. She's the CEO of Wheatbelt Power Company. Did you know that up to 10% of the average consumer's energy bill is wasted on vampire electricity?
And according to a Harvard University study, the annual total vampire electricity wasted in homes equals the output of 12 power plants.
That's a huge problem. Vampire electricity is wasting energy and money.
Before we came up with a solution, we did some research and also met with engineer Paul Ruggerton.
First, we thought we'd capture solar energy by using tiles in our homes, but then we also talked about making a phone charger using a wind turbine attached to our cars.
Then we started discussing energy in our own homes. We decided we all wanted to tackle the vampires and cut back on wasted energy.
Since we're all part of the problem, we all want to be part of the solution.
We began by discussing ideas that already existed. We researched smart thermostats and the way they save energy. We discovered they automatically adjust temperature settings when you leave your home.
This led us to our idea. We decided we wanted to create a product that automatically stops wasted energy within our homes. We found that smart outlets already existed, however they are not automated.
Our solution, called Project Garlic, is an innovative smart outlet system that is automated to turn off unnecessary devices when you leave your home.
Why do we call it Project Garlic?
As the legend goes, garlic vanquishes vampires, and it's our goal to vanquish vampire electricity.
Here's how Project Garlic works.
First, you put the hub in your home and plug in the outlets to the devices you'd want to make sure to turn off. Based on our research, some of the biggest energy vampires are centered around entertainment like TVs and gaming systems.
Next, the hub would connect to a phone app, and you can use the app to set a virtual home area using GPS coordinates. The app tracks your location, and once all the registered devices leave your set boundaries, the hub will automatically turn off the connected outlets.
We used Raspberry Pi to make a prototype of our project and prove that it could work.
Raspberry Pi! Yum!
Actually, Raspberry Pi is a single-board computer that we programmed using Python as our coding language. We use Python to make a functioning code to show that when someone is far enough away from the hub, it will turn off a light.
Our goal was to get the GPS sensor to work to prove our solution could be possible. We ordered the GPS module for the Raspberry Pi, and when we first received it, we didn't know how to code it or even use it.
Once we figured out how to wire it up, we had our coach help solder the pins to the module. Then we used tutorials to see if we could get the GPS to work. At first, we weren't successful.
After about 3 weeks of trying everything we could think of, we figured out that the problem was right under our noses. We found our way into the Python module that the GPS used, and we discovered that it was using a different syntax for strings only available in newer versions of Python. Thankfully, after we went through and reformatted those, that got it working. However, the information given by the GPS was super cryptic and we couldn't interpret it.
We discovered that listed speed, velocity, and orientation in addition to showing latitude and longitude coordinates.
After finding out how to read the latitude and longitude coordinates of the user, we set coordinates for the hub and proved that it was feasible.
From there, we used the Haverstein formula and successfully calculated the distance from the designated coordinates to the GPS, which in this example would be the hub to your phone.
We will simulate how this works now. When Hunter leaves the designated home area, in this case a portion of our room, the green light will turn off.
After we created our prototype, we shared it with an electrical engineer named Dr. Voyametic. He gave us a lot of tips and said our concept could work. He gave us the suggestion that we use Wi-Fi instead of GPS coordinates.
We also wanted to make sure that our product would have an impact on others. We sent out a Google form to collect feedback. We received 99 responses from around the country.
And we found that 45.5% of people use 10 or more power-sucking devices in their homes.
We also asked people to share what their monthly electricity bill is. The average was about $184 a month.
Because we discovered that up to 10% of electrical bills is wasted on vampire energy, we estimate that our project will save a household up to $220 a year. In the United States, $26 billion is wasted annually on vampire electricity. With that kind of money, we could give away nearly 600,000 electric cars.
Our expert, Lacey, shared with us that the best way to stop vampire energy is to be diligent in unplugging devices when not in use. And our data indicated that most people don't unplug their devices when leaving the home, even for long trips.
That's where Project Garlic comes in. Instead of unplugging everything manually, Project Garlic will automatically shut off devices you've chosen so you don't have to worry about it.
The innovation is in automation.
Let us vanquish your vampires.